Geometric sequences. So we started off this chapter with general idea of what sequences are, tried to get some terminology down and such, and then last lesson we dealt with arithmetic sequences. And you just got to remember, an arithmetic sequence is one where there's a common difference between each term. It's the same amount. If you were to graph an arithmetic sequence, it would look like a line. It's linear, right? So arithmetic sequences are linear. You can see the graph here to the right. Geometric sequences are not linear. They're exponential, and they can curve up or they can curve down. It depends on the sequence. Sequence can head up and the sequence can head down. It can go both ways. So instead of having a common difference, we're going to have a common, anybody remember way back to Algebra 1? Common ratio. Ratio, wherefore art thou ratio? That might be Horatio, but if you don't pronounce your H's, you're in great shape. All right, so common ratio, basically any two consecutive terms, so is a constant. So the ratio of any two terms is a constant, and it's called the common ratio, and it is R. So whereas you had D with an arithmetic sequence, that common difference, now we have R, the common ratio. And the common ratio is pretty easy to figure out. All you need to do is take two successive terms, take the latter term, and divide it by the previous term. Now here I did the second and the first term. You can do the 8th and the 7th term. You can do the 50th term divided by the 49th if that's all you know. You don't have to do the second and the first. So whatever, as long as it's two consecutive terms, take the latter, divide it by the previous, and you'll get the common ratio. So that's all you got to do here. So piece of cake. If we wanted to do this one, if we did 15 divided by 5, then we can clearly see that our R is 3. So what's the common ratio of that arithmetic sequence? 5, 15, 45, 135. It is a common ratio of 3. And you can see the graph there. Again, the x-axis is which term it is, right? The first term is a 5. The second term is a 15. The third term is shooting up all the way to 45. And you can see this thing's heading up quite quickly, right? Off it goes into the wild blue yonder, and away it goes. So that's the idea. So we got to have a recursive formula. So the recursive formula, some put the R in front, some put the R in the back. It doesn't matter, commutative property, right? And the second A is n minus 1, A sub n minus 1. You always got to associate recursive formula with the previous term. Again, that's the idea with the recursive formula. If you know the previous term, then you can get the next term. Recursive formula. So if you know the previous, you can get the next one, hence n minus 1 is the previous term. If you take the previous term, multiply it times R, and there you go. You've got the next term. If you would think back up to the original sequence, the first number was 15. We found R to be 3. So, I'm sorry, first term was 5, and we found R to be 3, and so 5 times 3 is 15, you get the next term. Now, if you want the one past 15, 15 times 3 is 45, you get the next term. How can we get the next term? 3 times the 45, and et cetera, on and on you go. But again, recursive formula, right? Previous term. Got to know the previous term. So it's just simply R times the previous term, or the previous term times R, however you want to think of it. So write the recursive formula for the geometric sequence. That shouldn't be hard for you guys. Basically, all you need is, it was your chance. All you need is R. All right, go ahead and find R, and then write the formula. You're going to have an A, so all you need is to stick in R. That's all you need. Just find. All right, so hopefully you thought that was too menial and below your height of intelligence, because R is obviously negative 4, and then it's times A sub n minus 1, right? And that's it, and then you're going to find the next term. By the way, notice in this sequence we alternate between positive and negative. And sometimes that will happen. So the graph of this is going to be odd looking. It's going to really have two parts. It's going to go off both ways. And it's not going to be continuous. It's discontinuous. You guys remember that? Just talked about that briefly earlier in the year. But you're going to have a discontinuous function here because of the switching back and forth. So the next term will be positive, the one after that negative, the one after that positive, the one after that negative, positive, negative, and away you go, and la-di-da. All right, so then let's get down to the real key things, and that's the explicit formula, right? General term or explicit. Both are interchangeable. General term formula or the explicit formula. And this one, you'll need the first term, and then it's simply r to the n minus 1. R to the n minus 1. That'll get you any term. So first term, and then times r to the n minus 1. All right, so let's take a look at a little example here. Sven invested $1,000 in a money market account with an APR of 5%. His account balance can be represented by the sequence 1,000, 1,050, 1102.50. What happened to my zero there? It's money. All right, $1,102.50. Dot, 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 dot. What will be the account balance after 20 years? Let's find the explicit formula. What do you say? Explicit formula. And to find the explicit formula, we need, all you pirates, you are so dead today. Come on. Wake up out there. They're lying. All right, so find R. Once you have R, then you're going to find A sub 20, right? So go ahead and do that. Find R, and then use that formula to find A sub 20 for Sven, and you'll be golden. By the way, we doing an exponential growth or an exponential decay? This one is a growth. You would hope your money grows. Not good when your money decays. Okay, so did you get 105 for R? Remember growth factor and things like that? And we've got a positive value there of the base. So this thing is going to grow. Again, just take a previous 1,050 divided by the 1,000, get 1.05. And then it's just going to be 1,000 times 1.05 to the 20 minus 1 or 19th. $2,562.95 for Sven. Sven is happy. All right. He had to wait a long time for that money, though. But he only started with $1,000. He didn't do anything else for 20 years. Just let it sit there. And again, if he lets it sit another 20 years, it'll start to do something. And if he could wait like 100 years, he'd be in business. But then again, we might be using Bitcoin by then anyhow, so what does it matter? All right. Yes, throw in a little Bitcoin for you. The correlation between the APR and the R value. See any connection between the APR and the R value? The APR and the R value, right? And that is a direct correlation. 5% is going to give you 1.05. Okay, B, write the recursive formula, the simplified explicit formula, and find A sub 25 for the sequence. Look at all that. We want recursive. We want simplified explicit, and that means there's no A sub 1 there. And then we want A sub 25. We want you to do it all. All right, you go ahead and do it at your seat, and I'll do it up here while you're doing it there and see how far you can go. If you need to, look up and get a little bit of help if you need to. But I'd be a pirate to get started if I were you. Not a Pittsburgh one either, by the way. Definitely not a penguin. What a name. Penguins. I'll tell you. Oh, that was that one. Let me back up here. Taylor, welcome. All right. Whoa, love that when I do that. Okay, you guys may have left your explicit formula like this, and to do what you want to do, it will get you there. I mean, you can, whoa, what's that comma doing there? Get out of there. You can leave it like that as far as if they didn't ask you for the simplified explicit formula. So if you're going to do a sub 25, you can go right now and find a sub 25. And look, if I were doing the question and I didn't know how to simplify that, then at least I would finish off and get a sub 25, right? Again, all recursive, piece of cake, knowing R. So that's the general, that's the explicit formula, but it's not simplified yet. So you got to simplify that is what we really want. But you can use it in that form if you don't know how to simplify it to end up here. So let me just show you. We can play around with this thing and have a little fun with it. So I'm looking at the 81, and I'm thinking about an 81, and I could think of 9 squared, or I could think of 3 squared squared. So I could and again, this is all times the rest of the stuff. So that could be actually a 3 to the 4th, 81. Isn't that fun? And I could take the 1/3, and what if I call it 3 to the negative 1? Because isn't that 1/3, 3 to the negative 1? So then let's go ahead and take care of this negative. And this could be 1 minus n. So now we have 3 to the 1 minus n, and x to the a times x to the b equals x to the a plus b. So what do we end up with? 5 minus n, and that would be the simplified explicit formula. Now, I'm not sure if anybody took it to that point, but that's where it really should have gone. Again, you'd say, well, I wouldn't have known to find all those like bases, and it only works when that front number and the base work out. But that is the simplified explicit formula. And it's why I said, look, you don't have to go that far to actually find a sub 25. As long as you do the black box correctly, then what do we get here? 4.15 times 10 to the negative 3. Am I reading that right? What do we got? 1 over 3 to the, let's see, let's finish it. 81 times 3 to the negative 24th. Small number. Very, 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 very little. .868 times 10 to the negative 10th. 2.868, again, depending on where you're rounding, times 10 to the negative, calculator dying, 10th. Okay, really small number, but that's the way this thing is heading. All right, so again, would you have known to do all of this simplifying? Maybe not. Should you have been able to get the recursive formula? Definitely. Should you have been able to at least do that very one substitution explicit? Sure. You could have used that then to get the final a to the 25th, and the other is just a little bit of fluff that they are looking for you to learn, but not as much of a big deal. Okay, Next example. Do you guys have that in your notes? Where did that come from? So let's go back to the generalized explicit formula and see if we can deal with that. Again, we got k and a sub k and n and a sub n. And so let me see if I can break this down a little bit more simplistically for you. So that's the second term equals the first term, right? A sub n is the second term. A sub k is the first term. And I don't mean like first, second. Let's say a sub n is the latter term, and a sub k is the earlier term, and that's times r to the n minus k. So n is the number of the term, of the latter term, minus k, the number of the earlier term. I think if you think of it that way, it'll be a whole lot easier to deal with figuring it out when they give you a couple terms. So again, we don't know the first term. We don't have the sequence in the beginning like we did the previous example. So we're not ready even to find r and all that kind of stuff, except that we use this formula. And again, once you understand the nuts and bolts, it's not so bad. So let me go back to arithmetic sequence. So arithmetic sequence, latter term equals the earlier term plus the n value of the latter minus the n value of the earlier times d, and you can get d. So here with r, same concept. The latter term equals the earlier term, only this time it's times r to the n number of the latter term minus n number of the previous. So put it into practice. There's the latter term, right? 64. That comes first, latter term. Earlier term comes next, right? The 4. Then it's times r. And what is the exponent? The n value of the latter minus the n value of the earlier. So 64 equals 4 times r to the 7 minus 3. Okay, this is just an exponential equation. And so you have to go back to thinking, how do we solve exponential equations? Well, you isolate the variable, right? You isolate the variable and its exponent. So move the 4. So divide both sides by 4. So what's 64 divided by 4? 16. And that's going to be r to the 4th. So 16 equals r to the 4th. And at this point, what would you do? Take the 4th root of both sides. Do we need to deal with anything else when taking the 4th root? Plus minus. Is it always plus minus? Well, it is for a square root, and it is for a 4th root, and it is for a 6th root, and it is for an 8th root. Remember, any even root, you got the plus minus aspect. Any odd root, it does not matter. It's just positive. So you finish this thing up, and you get plus or minus 2 equals r. Plus or 2. 2. Oh, the brain, what it does these days, who knows. So plus or minus 2 equals r, and now we've got the r value, and now we want to go back, and now we want to find, let's see, write the simplified explicit formula. Okay, so simplified explicit formula, we're going a sub n, right, equals, in this case, a sub 1 is the earlier term, the 4, times plus or minus, right, the r is coming plus or minus 2, and then we're doing n minus, and remember we use the 4 as the front term, so it's n minus 3, right, the 3, that 4 was the third term, so we have to do n minus 3. So again, a sub n, this is our earlier term, and this is the n value of our earlier term to get an explicit formula in simplified form. This is another one where, again, you have a 4, and a 4 can be 2 squared, and you have a 2. So technically, if you're going to do this, the best way, you're going to make that 4 a 2 squared. And then x to the a times x to the b equals x to the a plus b. And we really end up with plus or minus 2 to the n minus 1, because a positive 2 and a negative 3 is a negative 1, right? We're adding the exponents. I just added a 2 plus n minus 1. 2 plus n minus 3, and you end up at n minus 1. Okay, so go ahead and find the value now, because now it's just simply substitution, right? A sub 30. And the only thing you have is n to put a value into. In this case, n is 30. So what is the value of the 30th term? Somebody gets it, raise your hand, let me know what you got. What is the value of the 30th term? Just punch it in. What do you got, Alex? 500 and say it again for me. 500.
36,870,900.
Anybody else concur with that number? Okay. And do we want to leave it just like that? What do you want to finish it off with? Plus minus. And you might wonder, okay, so what's up with this plus minus? So let's go back to the beginning. All right, so listen, just try to tune in here. I don't think it's all that complicated. But if you look back at the beginning, right here, right, we were given the third term. We don't know the fourth term, do we? We don't. We don't know the fifth term. We don't know the sixth. And again, we know another odd term. We know the third and odd term. We know the seventh and odd term. So this sequence could go 4, and then it could go, what is that next one going to be? 8? No, don't even want to think through the numbers. I have to play with it. But anyhow, we don't know if that next term, the fourth one, is positive or negative. We don't know. Because R could be either way. Could be positive, could be negative. We just don't know. And so it could go either way. If they would have given us an odd term and an even term, we would know. If one of them are odd and one of them are even, it alternates back and forth. If both are even, there is no odd term. But because they gave us an odd and an odd, we don't know what those even terms end up. We don't know if they end up positive. We don't know if they end up negative. And therefore, we have to find both possibilities. And it's either going to be plus 536 million, etc., or minus 536 million, etc. And we just have no way of knowing, therefore we give both, plus or minus. Both are possible because they gave us the third and the seventh. They'd have given us an even and an odd, we would have known. All right, let's go back to the geometric mean. Terms between any two terms of a geometric sequence are called the geometric mean, right? We had the arithmetic mean the other day with an arithmetic sequence, and now you have a geometric mean for a geometric sequence. So in this situation, we know that there's just one because it says find the geometric mean. If it would have said find both geometric means, then we know there's two terms between. If it would have said find the three geometric means, we know there's three terms between. Because it just says the geometric mean, we know that there is only one term between. So therefore we can say this is a sub 1 and this is a sub 3. And it's all because they just said the geometric mean. They said 2, we'd be looking for 2. They said more, we'd be looking for more. If you look at the last example here, and I'm gonna go there right now. If you look at this last example, they say find the 2. So we're going to call the first one a sub 1, and we're going to call the 5/4 a sub 4, right? Because we know we got to have a sub 2 and a sub 3 for the two geometric means. You follow? So they'll tell you how many are in between. You have to know that. Otherwise, you'd have no way of doing the problem. So you got to know. So look at this point, and I see my time's beginning to get away. Do you see that this problem in number 5 is basically the concept of the previous problem? Although we don't need to write it, the simplified explicit formula, we simply need to figure out how to get the second term. And how do we get the second term? We got to find the first. So again, all we got to do is take the latter term, 54, right? Equals the earlier term. Then comes the r. And do you remember what to do for the exponent? The latter end value minus the earlier end value, right? The latter is a 3, the earlier is a 1. This is 3 minus 1, right? So again, once you do it a couple times, it begins to sink in. So the latter term equals the earlier term times r to the latter end value minus the earlier end value. Okay, so let's move to 6. So what is that? 9 equals r squared. Take the square root of both sides. And again, we're stuck in this plus minus, right? Because again, we know the first and third. So you get plus or minus 3 equals r. That's really all you need now to finish off and find the second term. And you could go the shortcut route if you want to. Because we know the second term, I can use the recursive formula. Will that confuse you? Remember, when you know the previous term, it's easy to get the next one. So the second term is going to be the first term times r. That's all. Pretty simplistic in that. We're not looking for the 100th term. Then we'd have to use the explicit. So this is just 6 times plus or minus 3. And the second term is either positive 18 or negative 18. Or the geometric mean, that second term. And again, we don't know. We just don't know. A little interesting thought. This is the same as finding the square root of their product. If you did plus or minus the square root of 6 times 54, you would get plus or minus 18. That's just kind of a side note there. And again, that's if you have just one geometric mean. So if you want a shortcut on finding the geometric mean, you could do plus or minus the square root of the product of those two numbers. It's a shortcut. Takes you the same place. A little bit quicker way of getting there. Okay, let me see if I can use my last seconds here to at least get you going on this last one. So again, we got the first and the fourth. This one definitely alternates between negative and positive. We know that for sure because we have an odd and an even. So again, how would you start? What would you write for the first one? The which term? Latter term. I don't know why I'm in red. And then the earlier term, right? Times r. And what's the exponent going to be? 4 minus 1 or 3, right? By the way, when you take a cube root, there's no plus or minus. Now, we are going to end up taking the cube root of a negative number, but that's not a problem, right? What's the cube root of negative 8? Negative 2, right? Negative 2 times negative 2 times negative 2 is a negative 8. So that's no problem. The cube root of a negative number is always a negative, right? It'd be negative whatever. All right, if I had time to finish that, negative a half ends up being r, and then you'd finish it up from there. All right, and I don't have time to do the example. I am changing the homework, though, so everybody needs to write this down because it's a change. And if you can get Leah and Josh know. So I'm just giving you odds tonight. 1, 5, 7, 11, 15, 19, 21, 23, 27. And then the extra problem, just do 38. Don't do both unless you really want to do 40. Knock yourself out. All right. We're getting toward the end. We're getting toward the final, and I'm just going to give you odds these last couple days of homework. Okay? So, but take advantage of it. Take advantage of the fact that you have the answers, but make sure you're figuring out what you're doing. Have a